You may have heard of distributed property first. You ever remember what it means? You got it? there's no number there, always put in a 1. Alright, so I think we've got that down pretty well. It's here. Let me get are designed to keep orders of operation in mind. Okay? Orders of operation. Give me 4 numbers now. Will you have to look at that, okay? Got some? Okay, all right. I'll be curious to hear your thoughts on this when we get done with stuff, all right? I want to know what you guys were thinking. But you know what? Let's hear your thinking now. Go ahead. Who had it? Okay, you guys work together to get that? Who wants to be the spokesperson for the table? I haven't heard Dylan yet today, so Dylan, knock it out of the park.
We were just thinking of having we tried 13, 15, 17 before, and then on a calculator see how much I add up, and then figure out the numbers.
And that's an excellent thought. So you were doing some guessing and checking to find 3 consecutive. What's consecutive mean? In a row. Okay. What other information was important up here besides just consecutive numbers or numbers in a row? They need to add up to negative 51. Was there any more important information that you guys read in that problem? They all need to be what again, Nolan? They all have to be odd, meaning that no evens. Okay. So you kind of did a guess and check method, right? What numbers did you come up with? I'm curious. Negative 15, negative 17, negative 19. I'm going to write that down because that is the correct answer. Okay, negative 15. Now there's going to be a process to do this, and I'm going to tell you how I kind of thought about this. That's excellent. I like what you guys did. And we'll come back to that. I'll tell you my process, but I'm going to show you the exact way to do this type of stuff here in a little bit. So how many were kind of guessing and checking? I'm just curious. Was anybody guessing and checking? And that's awesome. That's fine. That's fine. Did anybody else get negative 15, negative 17, negative 19? All right. Excellent. We'll come back to this. Let's run on to the second page here quickly, all right? Okay, here we go. Guys, what I posted right up here, rules to solving equations that we're going to start looking at. We're going to end up setting up an equation to model that problem we just looked at, all right? And the whole idea was to use multi-step equations to solve real-life problems here today. This is going to be really handy for you. You might want to highlight this. You might want to put a box around this. But this part right up here, really important to refer to, okay? Really important to refer to. Ooh, there it goes. Nice. Pretty too, isn't it? All right, fine. I'm going to stand over here because you guys are a little freaked out right now. And that's okay. Rules to solve multi-step equations. Number 1 says what? Rewrite the problem if necessary. Can I show you what the heck I'm even talking about here? If I put 2 simple equations up here like this, if I put down 7 plus, I don't know, 2x equals 14, and maybe, you know what, I'll put 3 up here. 14 equals 7 plus 2x, and the last one, 2x plus 7 equals 14. If you're like me, I'm kind of, for lack of a better term, OCD. Anybody else in my boat? Everything's got to be just in its place. Okay. Which one of those 3 do you think I'm going to like the best if I'm trying to solve for an unknown variable? First, second, or third? Third one? All right. I just like to have my variables all the way to the left. I work better left to right, and I think that that's true for most of us because when you're reading stuff, you read from what? Left to right. Okay. So I'm not saying you have to rewrite it, but if you want to rewrite it, if you're OCD like I am, go ahead and do it. All right? So the first step, back on your notes, what's it say to do, guys? Rewrite it what? Necessary. Second one right here. Tell me what this means right here. Tori, this is what's, you're really good at this. What are we doing here? Distributing if possible. So if there are parentheses, we want to get them out of there, right? Yep, excellent. Okay. Who is my combining like terms king? Nolan, that was you, right? That was you, okay? Aren't you proud? I should get you a crown and write the combining like terms king and let you run around. You don't want that today? I have a couple of Burger King crowns in the closet back there. I could write that on there. We'll call you the variable king today. How's that sound? I like that. All right. Combine like terms. Nolan gave us an excellent example of that. Are you guys okay with this? Okay, we've already done this. The 4th step. Undo any what? Addition or subtraction, undoing multiplication or division, all right? These are our inverse operations right here, right? So guys, these are pretty easy right here. Example 1, solve the following equations by using inverse operations, okay? Do I need to rewrite this the way I am? No, so I'm good. Do I need to distribute? Are there any parentheses?
No.
Take a look at the left side. Anything to combine? Right side, anything to combine? Okay, well, it's just kind of by itself right now, right? I think some of you guys are a step ahead of me, and that's okay. Step 4, then, undoing addition or what? Subtraction. So look at your variable. Center your attention around your variable. Is there any addition going on with this variable that we're trying to isolate? Addition of 6. What's your inverse to that? Subtract 6 from both sides. All right, so let's do that. Subtract 6 from the left. Subtract 6 from the right. Again, inverses cancel. So on the left-hand side here, plus 6's are. Plus 6's are just going to do what? Plus 6 minus 6. 6's are gone, right? What are you left with on the left, kiddos? 8x equals what on the right? 8. You have 8 times x now. What do you do? Divide by. What's your solution here, kiddos? X is 1. Okay? Not rocket science. And I'm probably sure you've seen some of that before, right? Okay? I don't like the way part B is written. I do not like part B at all. Okay? Where do I like to have my M at? Out in the front. Okay? Kelly, can you help me rewrite this thing? Okay. That would work. That would work. Can I make this a little easier? Is that okay? First of all, that minus m is really minus how many m being? It's minus 1m, okay? Kelly, since you started working with the m, I'm going to start working with the m too. I'm just going to call this minus 1m right off the bat. Are you okay with that? All right. What kind of 7 is still there on that right side? Could I write plus 7 for that part right there? Could I do that? So 7 minus m would be equivalent to negative 1m plus 7 is what you're telling me. Agreed? All right. Still has to equal what value here? 10. Okay? Guys, if I write 3 plus 4 equals 7, and 7 equals 3 plus 4, are both of those equations the same? So if I have something on the left and something on the right equation, I can automatically just do what? Flip sides, keep signs the same. Okay? Check it out. Is my m still negative here, like it was up here? Is my 7 still positive like it was here? Is my 10 on the other side of an equation still positive like it was on the other side of an equation here? It is, isn't it? Okay, so let's rock and roll. Parentheses to deal. Combine like terms. No. What are we going to undo now, Kelly? You finish the rest, okay? All right, I'm listening. Excellent. Divide by negative 1. And finally, what's your solution? Negative 3. Very good. Very good. You can show of hands how many are on board with me right now. All right, well, let's make this a little more difficult then, because that's too easy. That's too easy. All right? I'll leave that up there in case you haven't gotten that down. Any questions so far? This side of the room good? Everybody good? 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 Questions for me? No? Good? Okay. All good? All right. How about a show of hands here to help me start part A on this example 2? All right, Corey, rock it.
Do negative 2 times 4g.
Okay, so since there's parentheses, looks like to me you're distributing. So negative 8g.
And that u2
Excellent. All right. How about your next step, kiddo?
With minus 6 on both sides.
All right.
So it would be -8g is equal to 24. And then you divide by 8g on both sides, and g will equal over something.
So you're dividing by 8 or negative 8?
Negative.
Okay. And what was your solution here in the end?
-3.
Okay, so since these would cancel, and I should maybe cancel the 6's up here, we g equals -3. Good. Very good. I know I'm going through this quickly. Are you on board? All right. I want to volunteer for part B. Part B is tough. Who wants to help me with this? Jacob, you want to give it a shot here?
Okay, multiply the r and the 9 by 5
Okay, so you're going to have 5r plus what?
plus 45.
Okay, now I want you guys to be very careful on this second part because really how many distributions are taking place here in part B? 2. All right. Jacob, can I ask you a quick question? On that second distribution, what are you going to distribute? What value are you distributing? -2. Make sure you understand you're not multiplying by 2, but rather you're multiplying by a -2. So help me out. -2 times 1. You're on a roll here, Jacob. Go ahead.
-2 plus 2r equals 1.
Okay.
And then 7r.
Okay, where's your 7r coming from?
The 5r and the 2r.
5r and the 2r are both positive, so they would combine to 7r.
Plus 43.
Where'd your 43 come from?
The 45 minus.
Positive 45 minus 2, right? Okay, equals 1 still. All right, you're on a roll, kid.
Subtract the 43 from both sides. 7r equals -42. And then divide 7 by each side. And then r equals -7.
Close, so close. Help them out, guys. Negative what? 6. Very good. Jacob, that was awesome. Excellent job. Jacob, give yourself a pat in the back. If he doesn't do it, CJ, give him a pat in the back, all right? All right. Excellent. Working our way through these, how do you feel so far? Good? Okay. I'm going quickly. Are you with me? Anybody have any quick questions to this point? All right. Quick practice time on your own here. Run over here. I'm going to give you a couple minutes to try these on your own. Right up here. So go ahead and do that quickly. All 4 of them. This part right here where it says z/5, what operation is this really? Z divide 5. Okay, I want you guys to do this. Take a couple minutes, run through these quickly, make sure I know that you've got them down. When you're done with them, check with the neighbor around you. If you disagree, talk about why you disagree. If you get stuck on anything, see if your table mate can help you out, all right? So ask your partner for questions. If you have questions too and you're alone, raise your hand, I'll be around. So take a couple minutes and do those. Let's make sure we all agree. Many people have an answer for number 1, right? Everybody? Most everybody? Where did that come, the first one?
So what you're gonna do is you're gonna subtract 6 from both sides, and then you're gonna get z divided by 5 equals 6, and then you're gonna times 5 to get the answer.
How much? So 6 and 5 is your product. There you go. Yes, sir. All right, how about a volunteer? You go up and do the first one for me. Kayla, you've got the first one since you talked about it. Who wants the second one? CJ, the third one? Do they want the third one up there, Tori? Who wants the fourth one?
I'll do it.
Em, you want the fourth one? Okay.
Yes. Wait.
You'll have to, you know what? You'll have to go one at a time with that pen up there. Do I have it, or is that little pointer up there? Yep. Okay, so she's starting by subtracting 6. Everybody agree?
Yes.
Kayla, I should have you write for me all the time. Your writing's much nicer than mine. So z divided by 5 is 6. Just click the board somewhere. There you go. Click your pencil tool right below the arrow. So on that toolbar, there's a pen. Yep. Z by 5. And if you want to move your work over to the right, you can. Good. Very good. Z is 30. All right. Who's second? CJ? Kelly, thanks. Anybody have questions for Kelly? So we're adding 7 to both sides. Is that the way I understand it, CJ?
Yeah.
Okay, so you have 4x equals 36. Divided by 4. That's okay. You're doing great.
That looks reasonable.
Show of hands, how many had 9? Way to go, guys. Corey, you like those parentheses, don't you?
Yeah.
Everybody agree with your distribution, 3x plus 21? Any questions for Tori at all? So she's subtracting 21, she's got 3x is equal to a difference of 3. 24 minus 21?
Oh yeah, wait.
Okay, I'll save you some time. Okay, let's get used to the board here. Okay, you go ahead and erase, that's fine. Alright, so 3x is 3. How many have 1? Excellent. You guys are on a roll. Okay. Tori, can I ask one question though? That last step that you took down there, you drew a line up. You meant 3 there, right? Okay, so the 2 x's that are at the very bottom, pretend that those are actually like Chinese 3s or something like that. Does that sound good? So those are really 3 values down there, right? Excellent. Right? No, you guys are up there writing. You can talk through it too. You don't have to just.
Oh, this is bad.
Or not.
Oh, okay. So now I can't even read my handwriting. Okay, now I'm going to combine like terms. So this is going to be 3h. So
How come it's not 7h? I see a 5h and a 2h.
because this is a positive 5 and that's a negative
Okay,
2h.
alright, I'll buy that. Excellent.
So then you have 3h plus 22 equals negative 5.
Alright.
And then you're going to minus 22 from each side. And then 3h equals negative 27. Then divided by 3. And that cancels out, so h equals negative 9.
Awesome. Awesome job, you guys. That's good work. Thank you, everybody that participated there. Any questions about this right here? Let me have all 4 of them right. So I can see. Okay. All right. I'm going to make a little bit of room up here. Please give me a second. Okay. Example 3, you might want to put a star by this. This is going to be some kind of a grouping problem you'll see. This kind of goes through the whole, this is kind of opposite of the whole idea of the stuff that we talk about right here. So I want to make sure you understand, but a grouping problem involving a fraction bar. Here it is, guys. Fraction bar. You might have something like this. You might have something like x plus 7 divided by 4 equals, I don't know, 12. Something like this. This is just a special example right here that I want to make sure that you understand. This is called like grouping. This is called a grouping problem involving a what, guys? Okay. Anytime you have something like this is what I would encourage you to do, all right? This x plus 7 is really in parentheses. Even though it's not going to be written that way, that x plus 7 is really going to be in parentheses up there. All right, so anytime you're looking at a book problem like this, if you have something above a fraction bar, there's really what around it. But it's not going to show up that way in your problems, okay? Here's the deal. In something like this, I've got to get rid of this 4 down here. So up top, you have x plus 7 divided by what here? 4. What am I going to have to multiply both sides by first? So times this by 4 on the left, times this by 4 on the right. Here, the 4's will cancel, okay? So instead of being just left with a number up here, you're left with an expression which is x plus what, gang? 7. X plus 7. And that's going to equal, what is the product of 12 and 4 on the right? 48. Now it's just a simple one-step equation to that point. 48 minus how much? 7. Okay, so if you ever see grouping problems involving fraction bars, you actually start by undoing the division first in something like this. Because remember in our notes, you undo addition and subtraction first, right? And then you undo multiplication, division second. That's true except for this type of problem. Here we have to undo what first? Undo your division. Now we're going to undo the addition. So what are we going to get for a solution here, kids? 41. Okay? X equals 40. Okay, so here's the deal. Why is this stuff important? Well, here's a perfect example. You guys remember these types of shapes right here that we talked about the first day? What types of shapes are they? Quadrilateral, right? Okay. I have trouble saying that word too. In this geometric application, we have some expressions written for the measure of each angle in here. And our job down here is to write equations, solve for x, and then find the measure of each angle. Ooh. Well, what do we know about quadrilaterals again?
360.
They all add up to 360. So I can say I have angle 1, angle 2, angle 3, angle 4. I have to add all those up so they equal what value? That is going to be the part of your equation you're going to start with. So the equation part of this, I'm going to put it up here actually. Your equation, here we go. I'm going to start down here. I'm going to go x plus my second angle of x minus 17 plus the next angle of x plus 35. And finally, what's the expression for my last angle? X plus 42. I gotta squeeze this in here. Come on, Parson, you can do it. You can do it. What's that gonna equal? 360. I'll kind of put it like this here. All right, that's the equation. All right, so help me out here, gang. Are there any terms on the left side that I can combine now? What are they? All the x's. When I don't have a number in front of the x, the implication is that that's how many x's, guys? 1. So 1, 2, 3, 4 x's, right? Plus. Got to be careful. That was the x's that we combined. 1, 2, 3, 4 of them. Okay, I'm going to start this way. I'm going to start with the positive values first. Positive 42 and positive 35 is a positive 77. Is that right? Okay, positive 77, and combine that finally with what kind of a 17? So it's like 77 minus 17. Where are you? 60. So I'm going to call this 4x plus how much, kiddos? What's that going to equal now? Hey, the equation's set up. Isn't this stuff we've been doing right here now? Isn't this all stuff we've been doing right here? What are you going to subtract? Subtract 60 from both sides, right? And, okay. You got 4x equals what value here? Divide by 4. I'm not very good at math. I think it's 75. Okay. Don't tell Mr. Gassman that. Now, here's a question. And this is the part of this class that I want you really to hone in on. All right. Hey, we found x. It's 75. We're done, right? Why not? But check it. But read specifically. What's the problem want us to do? Find the measure of each angle. All I've done is come up with a value for x, right? Thoughts on what you might do then to figure out each angle once I know that x is 75 at this point? Anna Gates, help me out, please.
Take the 75 and put it in the angle.
So you're saying right here, I have an x all alone, so this angle must be how many degrees, kids? 75. How are you going to find this one, Hannah?
75 minus 17.
75 minus 17 right there. That's 58. Right? It looks like 5 snowman, but it's a 58. All right? Never mind. Next one looks like 75 plus 35. Guys, disagree with that? 110. How about this last one? 117. When I go 75 plus 42. Now, guys, the beauty about problems like this is why I love problems like this, because me, OCD, would take all 4 of those numbers and do what with them now? Add them up and see if they total what value. Check it and see. They do, don't they? And once I know that those values total 360, how do I feel about my work that I've done now? I've pretty much been able to say, hey, I know I'm right, okay? All right, let's rock and roll here. Next page, quickly. I should back up. You guys all have that down. I know I'm going quickly here. All right. So, you remember that lead-in question, guys? You guys remember that lead-in question? It says write an equation to solve problems. Doesn't this problem kind of look like what we started with thinking about? It does, doesn't it? This here, it does this. Let's just do this. It says find 3 consecutive integers that add up to what? 129. I don't want you to guess check it. I want you to know how to do this. And this is how it works, okay? This here says 3 consecutive integers. Are they even or odd or neither? Neither, right? Doesn't say even or odd, does it? Okay, so if I start with one integer, 4, what's the next consecutive one? 5, right? And then the one after that would be 6, all right? Well, here's the deal. Do you guys know what the first integer is? Let's just pretend it was a huge number. We didn't. Okay. I don't know what the first integer is. I'm going to call it x. Okay, the x is like the 4 I started with, the first one, right? You said the next consecutive integer in that series after 4 would have been a 5, right? One more, right? One more than 4. So won't my second integer or my next consecutive one be, oops, yep, be an x plus how much more, guys? What's that make your third integer then? Well, in our example, 4, 5, 6, 6 was how much more than the first one I started with? 2 more. So what's an expression going to look like for the third one here, guys? X plus 2, right? Okay. Once I've assigned those expressions for your 3 consecutive integers, what are you going to do with them? Kelly, what do you think? So you took 43 right in the middle and went both sides, right? That's how I did that first one that we let in with. That's how I thought about that first one. I love to hear you think that. So you think the answer is 42, 43, and 44? Let's see if the work I'm going to do right here matches that, because that is correct, okay? Guys, if this is what I want, the first, second, and third integers, these 3 expressions should add up to what value? How about an equation? What's it going to look like? All those expressions added up has to equal what value totally? 129, right? How many x's are there, kids? 3, right? So I've got 3x. The 1 and the 2 would combine to, and that's 129. All right? If I go ahead now and subtract by how much? 3. I'll move my work to here. We have 3x equals 126. Do you guys buy that? What's that make your x value when you divide by 3? When I divide by 3, I've got 42, right, kids? Everybody okay there? Everybody okay on that? 42? Okay, so all I've done is say, hey, x is 42, but I want 3 integers. One expression was x, so if I throw 42 in like I did with the angles, what's that first number? What's x plus 1 going to be for the second number? What's the next one going to be? 42 plus 2 would be 44, right? Holy cow. It works. It works. How do you guys feel about this today? Go ahead and stop right there. We'll come back to some stuff tomorrow. I'll send out the assignment again today, the new one on the computer. I think I know what happened on it, and you shouldn't have any more submission problems the rest of the year, hopefully. Hey, real quickly, hold up.